So now that we've used the least common denominator to add and subtract rational expressions, we can use the same idea to help us solve rational equations. So basically a rational equation is any equation that has at least one rational expression in it. Now, in past lessons in Algebra 1 and early on in Algebra 2, when we've had linear equations that have had fractions in them, what we've basically told you to do is to find the least common denominator and use the least common denominator to clear all of the fractions so that you are left with just the given simple equation without any fractional parts. And so that's basically what you're going to do here. You're going to try to find the least common denominator, and you're going to multiply it times everything across the equation, hopefully clearing out all of the denominators and being left with just a simple algebraic equation. And so it doesn't require us to change every single rational expression in the equation, but it still does require you to understand least common denominator. So if you take a look here at some of this information, you can look at example number 1, and I'll just go through example number 1 with you real quick. We have a rational equation. We have x minus 3 and x plus 3, and you can quickly see that if you factor out the x squared minus 9, you also end up with an x minus 3 and an x plus 3. So we have all of our given parts here. So we can see that x minus 3 and x plus 3 is common across all of the denominators. And so we're going to use that actually to multiply to both sides of the equation. And when you do that, you actually end up canceling out different parts of the denominators so that you're left with just a simple algebraic equation. Now, here's the problem. If you multiply both sides of an equation in algebra by an algebraic expression, you then introduce the idea of an extraneous solution. So whenever we do this in rational equations, we have to check for extraneous solutions on the back end. And you can see in example number 1 that we check both of the solutions plus and minus 1 for extraneous solutions, and they both work out. So be sure to always check for extraneous solutions. So in the next couple videos, I'll just go over some sample problems. If you'd go ahead and get started and try to work those sample problems, you can come back and watch the videos for the solutions. Okay, if we take a look here at sample problem number 1, first thing we want to do is we want to factor out all the denominators so that we get a clear look at what the least common denominator would be. And if we look here, we can clearly see that x plus 1 and x plus 2 is our least common denominator. So I'm going to want to multiply those terms to both sides of the equation. Okay, now I've set this up. So what's technically going to happen here is I'm going to take this entire expression and I'm going to multiply it. I've got to distribute it across this addition, and then of course this is just going to the 1. And so when you do that, we're going to create a situation where we have some canceling out. So I'm going to go ahead and do that next. Okay, and you can see here I've done the distribution. I'm not actually multiplying all this together because the polynomials would get very confusing. By leaving all of this in factored form all the way through to the end, it makes this simplification at the end much easier. So now we'll go ahead and cancel out anything that can be canceled out within each particular part of this. And the desired effect, obviously, is to get all of the individual parts of the denominators canceled out. So we're left with something simple like this. And so now we have a very straightforward algebraic equation that you can just simply work from here. So go ahead at this point and you're just going to distribute everything, combine like terms, and then solve for the missing x at the very end. So I'll go ahead and work that forward. And now you can see here we get to a simple quadratic equation after we combine all the like terms, and a quick factoring and use of zero product property will give us the values for x. So because we're dealing with a perfect squared trinomial, we can see we get two values of x equals -1, so we have a little multiplicity going on here. Now, here's the thing. Since we introduced a quadratic, and we technically did introduce a quadratic expression, but since we introduced any algebraic expression to the equation through clearing the least common denominator, we have to check to make sure that our final solution works, because it could be extraneous. So we definitely need to plug this back into the very original equation to verify that -1 is actually going to work. So we'll go ahead and check that. And a quick setup of this, you could punch all this into your calculator if you felt like you needed to, but you can see really quickly here that you're going to end up with a situation where you have 0 in the denominator of one part of this, and if any part of this is undefined, then you have an issue with the solution. So in this case, since this is undefined, we have no solution for the answer, so the -1s aren't going to work there. Alright, and so that is your first example of solving a rational equation. Okay, for this last sample problem, we're going to work it the same way. This one actually is a little bit more straightforward, given the fact that our least common denominator is very simple, especially since we have the entire equation equal to 1. That makes life a little bit easier. So I'll go ahead and start by setting up the least common denominator and distributing it to each part. Okay, and you can see here that we're simply going to just distribute to both parts, and obviously multiplying times 1 just equals itself. So I'll go ahead and take that next step. And from here, I can start to cancel out individual parts of the denominators and rewrite our remaining equation. And in the process of doing this, I'm going to go ahead and redistribute. So I'm going to distribute the 2 there, and I'm going to distribute the x there, and I'm going to go ahead and FOIL this right side so I can just kind of do this in one step. Now that I've got this in a simpler format, I can go ahead and try to get everything on the left side and make it equal to 0. In the process of doing that, a number of terms cancel out. So we end up with 4x equals to 0. Very straightforward problem. So we have x equals to 0. Now, we just simply need to check that for extraneous solutions, since the fact that we use the least common multiple with an algebraic expression to clear the denominator. So we'll go ahead and check that next. And you can see here that this actual solution actually checks out. 1 equals to 1. So we can say that x equals to 0 is a valid solution to this rational equation. So now you've seen 2 sample problems, one with an extraneous solution and one with a valid solution. But once you get comfortable with the least common denominator, you should be fine with this information.